All right. Well, let's get going. Welcome, everybody. Give until 7:05. How's everybody doing? A little afternoon coffee never hurts. Is this still happening? Are we going to do this? Where's Rob? Yes, we're going to do it. If you haven't noticed, I've been really good with the schedule since on the beginner boost. I've made it on time every time. Some of the other times I've streamed, I'm not so punctual. Sometimes I'll say, "Oh, we're going to do this thing," and then we don't do it, and it kind of fades. But on the beginner boost, I'm definitely going to do it because I can promise to those times. When I have a conflict, I can always move it or push it back. And one other thing I've been doing is I've been making sure that during the day to change the title to tell when the time is going to be for that day. So I feel like this is important. So people who want to be here can be here. I mean, I know this time we had people from, although I mean it was the same way last time, but this time we have people that are staying up till 4 a.m. Some of them to be able to attend live, and I want to be able to respect that. I am going to wait every time until about 7:04 after the hour because it takes people a while to trickle in, even if I start at 5 minutes to. There's probably some like best practice about how to do that when it comes to Twitch streaming, but that's just the way I do it. Hot tub bikini stream. Who knows? It might be a bikini stream sometime. How's it going, ARV? You never know. It might turn into one. I've been on a bunch of hot tubs lately, but that would just give me permission to take my shirt off. Nobody wants to see that. At least not right now. How's it going, Hobdoms? In Nigeria? Wow. Well, that's good. You got the right time zone then for you. How's it going, Graph Guy? Thanks for those subs, by the way. I see those subs over here. Really appreciate that. Subs and Patreon, all that stuff. That money is just going to go back into the system. Eventually, I want to be able to pay people to help edit the videos and get them out faster so that I can... hey, Pun Master, good to see you. One of these days, we're going to be able to do that. At some point, I might actually be able to hire a team. And when we do have a team... I'll be making lots more videos because then I just have to make a video and hand it off. And but for right now, as you guys know, I've got to hold everything down together and stuff. Speaking of which, let me lock the door. I do love my family, but and I don't mind an interruption. But today, for at least 2 hours, I want to guarantee that we can stay on business. Speaking of business, it is 7:03, and that means we're going to go ahead and start now. So what are we going to do today? So as always, just the rec feed. If you don't know, if it's your first time here, everybody go to the URL github.com/rwxrob/boost, and we are doing this. Oh wow, yeah. We're going to be using this GitHub repo as opposed to anything else. And everybody at this point on day 3 should already have a GitHub account set up. You should have already been able to edit files. You maybe have already added a directory and put stuff in there, a README file. You should have already experimented with Markdown and read through the beginning Markdown material. We're on day 3, and one of the things about the boost that I'm doing is we're proceeding and we're building on top of other skills and stuff and discussion most of the time. At some point, there'll be divergence where you can do one or the other at the same time. Doesn't matter. But up to now, if you don't have that other stuff done and you haven't been taking the time to do it or watch the videos or because the video is just a minor piece of this, you're going to be lost. You're not going to be able to do it. But you can always go back and rewind it. But I'm going to make a bunch of assumptions about where you are now already. And that includes knowing what page to go to. Yeah. Yeah. Well, I don't know about explosions. We'll see about that. So yeah, just a reminder too, if you put an exclamation point in front of anything in the chat, nobody will see it except for you and the other people in the chat. That will not show up on the main window. All right. So if you're watching me earlier today and later tonight, I actually made a command line Twitch client to set the title and to do some stuff with Twitch from the command line, and it uses a number of tools and stuff like that. If you wanna watch me offline tonight later, I'll be doing some more of that, and I'll be making a dot files container to use at work. All right, so let's get going. We talked about the scientific method last week, or yesterday, and I turn the music off. There we go. And let's see, what else we got here? Yep, I think we're good to go. I'm going to go ahead and read this again. Nope, we did not learn how to use auth. We're not going to be, I'll be doing separate videos on how to use auth. That is not going to be part of the boost at all. Yeah, so we did the scientific method, and now we're going to be doing the Linux approach. Okay, so there's going to be a lot of talk today. Again, we've had to kind of build up to where we are, so that you understand why everything's happening the way it's doing. And so this first video here, let's set that. What's Linux? History of Linux, GNU Linux. You can follow if you have a Mac. Yeah, we talked about that on the first day. So the way this works, by the way, if you're new, is I'm gonna go into movie mode. You'll see my little tomato timer start up, and we'll be making videos just kind of like, hey, we're recording. You're in the studio audience, so we're gonna do that. Do Macs use Linux? Does Windows use Linux? The Unix philosophy, how Linux architecture works. I'm just going to go ahead and just talk through this whole thing, changing the title as we go, and setting markers for each one of those things. So let's get ready for our first video. I guess we could still keep these combined. Should we do that? Let's do that. All right. All right, so let's add a marker here and we'll get going. I don't know, my Pomo's not starting. That's been bothering me lately. Actually, let me try that again. VIC. Pomo's start. Oh, that's why it never gets there. There we go. Let's do that. All right. So what is Linux? Where did it come from? Why do I care? All of that. So we're going to do a quick video on this. So we'll try to keep this one to 15 minutes. So Linux is an operating system. Bottom line. Well, what's an operating system? An operating system is the thing that makes your computer run and work. It makes it operate, right? So that's it. That's all Linux is. So we have Mac as an operating system. We have Windows, which is an operating system. And we have Linux, which is a modern operating system that's better than all of them. But how does that relate, and why do you care? And for that, you have to have kind of a history. And so I'm going to jump into the history of Linux real quick here. And I'm not going to put any diagrams or anything. I'm just going to just go right through the videos in 15 minutes and get this done. So back in the day, I think it was probably 93 for Linus Torvalds, and we could probably bring him up. So let's do this as if you were doing it, right? So who is Linus Torvald? So we're going through this so that you don't feel like you're a total noob when it comes to Linux. You can talk about it. So we'll bring up Linux. We'll bring up Torvalds in the graphic. There he is. There's a happy face for him. He's actually a pretty grumpy guy. He's gotten better. So Torvalds was a computer science person. He was into low-level systems. His professor invented Minix, which is another operating system for devices, and he's been fascinated. Linus Torvalds has been fascinated by hardware since he was a kid, and so he wanted to develop. At the time, Unix had been really popular. Well, what's Unix? Okay, so Unix is an operating system that was invented by AT&T Bell Labs, and you can actually there's a really great if you want to understand Unix, history of Unix dates way back. Okay, so if you want to understand Unix, you have to go way back. If you want to have a fun explanation, every Christmas we do this. This is kind of a tradition. We kind of make fun of a video that's coming up here, and you can go see the Unix video. So I'll just put all this stuff in there so you guys can go do your own stuff. History, the Unix operating system. There it is. So this AT&T archived video is absolutely hilarious, and you can see the guy reading from the teleprompter and everything. There's actually some really great videos of us making fun of this video. If you want to go back and watch them, actually, if you search my channel and if you search for Unix history, you can find this. It'll pull it up. This talks about the original, what it was there for. I mean, here's some of the first Unix systems that ever existed. Back then, I think the number is $3,000 a seat to even use Unix. It was highly proprietary. Everybody who used it was, very, pedantic, and they paid a lot of money for it. And you had to be in a really big organization to use it. This is Ken Thompson, the founding inventor of it. He's the guy who invented the idea of the Unix philosophy, and in short, what the Unix philosophy is that you take function, stuff you want to do, and break it down into little pieces of little commands, and then make it so that those commands can do things one at a time, and then they can send that information to something else. So you have like echo, hey there, that's a command, right? And then you could send that to another command. You could echo maybe, something like, I'm just making stuff up here. So 6 times 5, and then send that in a pipe to another program. And in this case, BC, which is a calculator. It's a reverse notation calculator, and you get a number, right? And you could add on to it and stuff like that. So the idea, the Unix philosophy, very importantly, is do one thing well. And the second piece of this, which people drop off of it all the time, and make sure it integrates with everything else. So there's lots of stuff you can get into there. The principle of separation of concerns, making sure that each one of your commands does something really, really well. Now the Unix philosophy has since kind of fallen by the wayside. And you get things that like kube control. So we've got more memory and stuff now. So the Unix philosophy now says I can do not just one thing well, but I have one monolithic command, and I'm going to bundle all of these little individual subcommands within it. And each one of those subcommands is as if I had been doing it one at a time, rather than because there's all the commands that Git supports. So the Unix philosophy has kind of given way to this idea of the Unix philosophy plus monolith, which means you get one master command and then it has a bunch of subcommands. And I've actually created some software that's related to that. And systemd is a huge controversy these days because it has really violated the Unix philosophy to the core. It means it's got everything in it. And so this is a big point of debate, but it's really important that you understand the Unix philosophy. Rather than building a big, huge, monstrous editor, you make a tiny editor, and then you use the editor to add things from the shell that can run to do stuff there. So let me give you a good example of that. So if I'm editing a file here and I want to say, I don't know, if I want to say hello there, hello there, another line, right? So instead of making a function inside of my editor, we're going to learn all this. Instead of making a function inside of my editor that adds comments and bloating up the editor, what we would do is we would make it so that the editor can send a command to the command line, and that command line script can take each line and modify the line as it goes. And I have a thing called comment, and it will send a comment, put those lines in front of there. That was a bad idea because it's not a markdown file, but you get the point. So this is an idea of separation, and we're gonna come back to this later, because when I talk about why I don't like NeoVim, or why I don't think Emacs is a good idea, or why systemd might not be into the true spirit of Unix, and we have all those debates, it's always going to come back to the Unix philosophy, which is do one thing well and integrate, make sure it integrates. And by doing that, we end up with this massive flexibility. So that was the basis of Unix. That was what sent Unix over the top. It made it the most important operating system ever invented, in my opinion, even far more important than the PC. Because why? Because ultimately Unix became Linux and BSD and a bunch of other brands of Unix, which we can look at in the, probably here in this little history. And you can see all the stuff that it became. So you have Unix coming here. You have all the BSD Unix. So BSD Unixes are down here. You have FreeBSD. You have the Mac operating system is Unix under the hood. We're going to talk about that later. You have Linux, which came from that. Minix, which was related to Linux. And you have HPUX, you have Solaris. And so people ask, well, what's the history of Linux? But what's really they're asking is, what's the history of Unix? And here AIX is very important. This came from IBM. You have SunOS, which then became, many other things. Open, was it? I forget. There's just, so this is where Unix came from. Why is it so important? Because Unix has been used, Unix and Linux have been used for systems that colleges have had, like, it's still in Pico CTF. If you go play the Pico CTF game, they'll give you Pico CTF is a free game to teach you to hack, made by Carnegie Mellon University, but it also teaches you a bunch of other terminal Linux skills. And a part of this is you can go over here and they will give you a free account. And if you log into their account, you can see they've got over 62,000 accounts on a single computer. So Unix and Linux originally were very, very multi-user, and it was because of Linux that we have the internet. The internet was built on a Unix system originally, and then later for Linux. And these days, pretty much every server out there is running some form of Linux and Unix. Linux has gone on to be included in everything. It's running inside of your watch. Your mobile phone is running some form of Unix underneath. It has a graphic interface on the top of it, just like Mac. Mac is Unix. Mac is a story I have to tell another day, but they literally took BSD Unix from the university, put it inside a Mac, put their front end on it, and charged everybody money for it, even though it's against the license. So I have a problem with Apple for doing that. But so if you have any kind of device today, if your refrigerator is a smart refrigerator, if your car has a system of Unix on it, it's probably going to be BSD Unix, it's going to be Linux, or some form of Unix. So the reason I say Unix is the most important platform on the planet is because it's the operating system that's literally underneath everything else, including every Mac and Apple device that's ever been created. So these days, Windows is now got it on as well, and so Windows has added its own kernel that runs next to its Windows kernel. Underneath that you can't see, but that's good for us because now we have a version of Linux that runs as close to the hardware as we can get on Windows as well. So Linux is taking over the world. And the reason Linux got so popular in history is because Linux was when Unix came out, there were two free versions. Okay, so SunOS was the first. It wasn't free, but it was open. Okay, when it was AT&T stuff, you couldn't even use it unless you paid them for like every single use of it. And it was really, really proprietary, and that led to a bunch of people trying to make things that were non-proprietary, free software as it's called, and that kicked off the free software movement. And that's where Linux came from, and that's where Richard Stallman is the other one. Richard Stallman. When you talk about Linux, you can't talk about GNU/Linux, as Stallman likes to call it, without talking about Mr. Richard Stallman. Very, very controversial figure who wrote all of the software that goes most all of the software to this day. Its name's still in the man pages on almost all of the stuff that's in the Linux when you run Linux operating system. But he didn't create the most important piece, which is the kernel. And so to this, he thinks it should be called GNU/Linux because of that. But the fact of the matter is, that Torvalds invented the kernel, but he didn't want to spend time with all the stuff around the edges. And so when they met, I don't even know how that meeting went. It's probably written in his book. I haven't gotten to it yet. You can go read about that. And that's how the stuff got hooked up. And then, so what that became was Linux. And so Torvalds was just trying to make a better kernel for the hardware he was playing around with. The kernel is the core piece of it's a core program that runs, that really communicates with all the low-level hardware. It's the most important piece of the thing. And Minix was a small one designed for really small hardware. And his professor made that, and he wanted to improve on it. So for his project at school, he made Linux. But he didn't have all the stuff to go on it. And that's where Stallman comes in. And so he created the GNU free software movement, which is a separate thing all by itself, which we're not going to get into, the American free software movement. But Stallman influenced the entire world because he was the first one that said, not only should you allow everyone to use software, but you should make it so that they're forced to share any of their changes to the software. And that was quite a legal difference from all of these other proprietary AT&T Unix-y kinds of things. And so that's why it became so popular, and it still is to this day. And in fact, there's a massive debate. We'll talk about licensing at some point. There's a massive debate about whether to do that or not. And the free software movement in most ways has morphed into the open source movement, which Stallman hates, because the open source movement just means you can use it for free. And if you make any changes, you don't have to give them back. So both of those are open licenses, but one of them is a permissive open license, which means, you can do whatever you want and then rebrand it and sell it, which is what Mac did. That's exactly, Steve Jobs lost his job and he got kicked out of his company, decided to get into 3D stuff, made Next Step because everybody was he also created Pixar at the same time. And then they said, please come back. We need to have you back to Mac and Apple because we're failing. And he said, fine, but I'm going to put Next Step inside of my operating system. And because he chose Next Step, which is built on BSD, right here, version 8, and he built it based on that. In fact, it used to be called that. Now it's called Darwin. And so because the BSD is a permissive license, he was able to put it inside of Mac OS. And to this day, every Mac user, if they get on a terminal, you can still see that you have Linux you have Unix on there, BSD Unix on there for free. And he can sell it and he doesn't have to give back his changes or anything. Linux, on the other hand, said, I just want you to give back the changes. And they created a license, the GNU public license version 2. And Linux to this day is still released under that license. There's another license, GPL v3, which gives certain constraints about the hardware that Linux can be put on, which pretty much tanked it. And now there's a big fight between Torvalds and Stallman about they've parted ways, and Torvalds only has GPL2. So I know that's a whirlwind history of all of this. SunOS was proprietary. But people often ask the question, should they learn BSD? Oh, look, see, the green ones are open source. I see. Okay, that's good. Mixed or shared source, and these are closed source. See, the thing I think is funny about making this closed source is that was a violation of the Unix license to do that. So Jobs pretty much just thumbed his nose at the legality of the whole thing. There's open source. Okay, so that's a whirlwind history of Unix and Linux, but that has given us this operating system that we're going to learn. The terminal that we use, the bash terminal that we're going to be learning and working with, and the previous terminal interactive shells, POSIX shell, this is going to help give some structure about where that comes from. For example, these all use shell, basically Bourne shell it was called. That was the interactive user interface, which we're going to get to from the command line. And then there was the Bourne again shell, and that's now the standard shell for Linux. It was the standard shell for Mac for a long time, and now Mac has thrown it out and put another shell called Z shell, which is licensed under BSD because it's more permissive and they can resell it. And now that GPL3 has really tainted anything from the Free Software Foundation. So I know this is a mouthful for you. Maybe you have to slow it down and rewrite it. But this has been a really whirlwind overview of Unix history, where it came from, and why you care. Every major thing that's done these days is there's a lot of stuff that's happening. This is not mainframe, by the way. So Unix was a distributed operating system. It was designed to be, smaller than a mainframe, even though people are running Linux and Unix on mainframes these days by using virtual machines and making a bunch of Linux machines on the mainframe, which is a completely different beast. We're not going to talk about that right now. But so I'm going to turn to answer some questions and review the thing here. All right, so you love that clip, the sweater. Yeah, it's pretty funny. System D, still use AIX? Yes, and you will use AIX a lot. And the reason that I need to tell you about Unix and Linux history like that, as Dapper King says, AIX is still a big part of the enterprise. And if you watch YouTube videos or Twitch streamers, they're not going to tell you about AIX and Solaris. In fact, Zorchenheimer recently had to learn he called it VI, which is the editor that comes on AIX. And he's been forced to use AIX at his job, having never even heard of it before. So the reason I think that this is the right way for you to start out your knowledge about Linux is because you're learning about the origins of Linux and why Unix matters, why BSD matters, where does it fit in. BSD to this date is still the most popular operating system for things like routers and stuff, because it's famed to be the most secure because they don't allow a lot of changes. And so that'll give you a context for all of the different operating systems, and you'll hear a lot of people talk about that. If you just scan through Twitch and YouTube, you'll see people doing BSD and you'll see people doing Linux, and they'll fight back and forth. And then, you can ask the people about what the best kernel is. But we'll be doing Linux for the rest of the boost. So there we go. Masood says, I've been learning embedded systems build, and I already have some web dev. Good idea if I learn embedded dev along with regular software development. Absolutely. I don't see why not, but we're going to be doing a lot of stuff that builds on embedded development, and we have a lot of embedded developers in the community, by the way. Intending to learn device driver stuff, yes. And as I said before, Linus Torvald's favorite thing is integrating hardware. That's why he made Linux, because he likes to tinker with hardware. So it's important that you remember that device drivers are a big part of Linux, and they always have been, and they will be continually. It's actually a really great way to get into that development. From what I'm hearing, we have a lot of embedded developers who do a day-to-day job in the community, and you can bounce those ideas past them about what to do. But I can tell you most of them are either using BSD, because it's smaller and it's got a more permissive license, but a lot of them are using Alpine these days. Alpine is a Linux that doesn't have GPLv3 on it. And so, but stick with us on the boost and you'll have a good launch pad to do all that. The first language we're going to code in is Shell, and then the second language is C. And we're going to talk about why C matters, because it'll help you understand how your computer works at the low level first. And then you can layer on complexity as you want to on top of that. Yeah, Unix C, UTF-8, same guys made Modern Computer Science. What is it? Robert Pike. He also made Go, by the way. Are you going to get into the difference between monolithic and microkernels? Hell no. No, you just need to know that those are just different ways of making, we're not talking about herd and stuff like that. No. This is a beginner boost, right? So knowing that there's a difference between them is the minimum. So now we've covered that. Okay. When you want to use Ubuntu, if you have to use NVIDIA tools, wouldn't you want to use Ubuntu? Well, we're going to use Ubuntu. I'm going to use Ubuntu as we go forward. Ubuntu is one flavor of Linux, and there is another chart for Linux history, which is really good. You can go look at that one, and we'll wrap up this video. So here, this is actually the image for Linux history is almost impossible to keep up to date because it changes all the time. There's so many versions of this thing. This is the one I most frequently look at. That's not it. They chopped it. Why did they chop it? That was dumb. Here it is. So I know you can't read this, but so you have the first Linux, and then you have all the different versions of Linux. Debian is the one that led to Ubuntu, which is the one that we're going to use. If you've heard of Kali Linux, it came off of Knoppix over here. And you might have heard of some of the other Linux versions and variations. You know, you can just look at them all. There's just so many of them. SUSE is still popular in the enterprise. Really, the only Linux, I think, the only Linux distributions that matter today, and people will yell at me for saying this, in the enterprise, the only Linux distributions that matter are Debian and Ubuntu. But if you're talking about containers, you're talking about Alpine, which is not listed here because it's so tiny. It's built on that. But in terms of desktop distributions, and there's people who have entire channels just dedicated to the differences between desktop distributions. We're not going to fight about that at all because we're going to use a command line for our stuff. So you can use whatever distro you want. Hands down, the most popular network and desktop distro is Ubuntu. It's just no debate. It's hands down the most popular. One of them, a popular distro, is called Arch Linux, but Arch Linux has no footprint whatsoever in the enterprise. So, meanwhile, Ubuntu has a huge footprint in the enterprise. Red Hat has a monstrously huge footprint in the enterprise. In fact, the Red Hat company, the president became the president of IBM recently. That's how big it is. I used it for years at IBM. I don't particularly like it, but that's the way it goes. And then there's SUSE, which is another sort of corporate kind of distro. Slackware is one of the older ones. It has no presence anymore, even though it's the oldest one. So these days, when we talk about Linux, that's almost immediately synonymous with three versions: Ubuntu, Red Hat, SUSE, and I guess Arch Linux. Okay. And of course, Arch is over talked about. The amount of conversations about Arch on YouTube and Twitch are way disproportional to the amount of people who actually use Arch for work. And I can't overstate that. You're welcome to use Arch if you want. The reason Arch is so popular is because of the Arch user repository, which is something that has a bunch of fresh modern development. It takes a lot more time to get started on Arch. By the way, Ubuntu includes Pop! OS and Linux Mint and a bunch of other ones particularly that are beginner friendly. Arch is not beginner friendly, even though it does give you a lot of access to it. There's many reasons to use Arch, but none of them are I want to work in enterprise. Even though things are sort of changing, you can use what you want these days because of containers, and we're gonna talk about that. Okay, so a lot of people here are going to have opinions when I get into the distro thing. That's all I really want to talk about that. Okay, let's see here. ZK. No, I don't want to see it. Reminder on a 6 debate. No. New versions of Linux, yes. Yeah. Knoppix is still being used. You betcha. Knoppix was the first Unix to come on a CD, and you could use it to save your computer by booting into Linux, and then you could go fix what Windows broke, and then you could put it back. And that's still why Knoppix is popularly remembered today. Gen 2 versus Arch users. Gen 2 is a version of Linux where you have to compile everything to install it. And everybody always thinks it's cool to mention LFS, Linux from scratch, which is not a distro. Linux from scratch is not a distro. I'm going to say that again. Linux from scratch is a book that tells you how to make your own version of Linux. And what else we got? Red Hat makes a ton of money off Linux. And they change everything they want. There was another popular Linux for a very long time called CentOS, which was basically a free version of Red Hat. Fedora is another free version of Red Hat. And CentOS has been destroyed. The project has been disbanded. Red Hat took it over and just said, we're not doing it anymore. Red Hat is a very controversial figure in the Linux world because of its involvement in, they invented systemd, which is highly controversial. These are again, the purpose of Beginner Boost is to give you tidbits of knowledge about what you might not know and to send you off to do your own learning and your own research. So I'm not going to cover all of this. I'm at least going to mention it so that if you hear about it, you can say, well, I'd like to research that more. And then you can go talk about that and do that your own research. Cause I think we're into 20 minutes on our POMO. And give it computers. Yes, Knoppix was used to fix surplus computers. Absolutely great for that. We are not going to cover package managers right now. We're going to cover those later. It is important to mention, though, that a lot of people would say that the distinction between a version of Linux is often boils down to the package manager. It's not completely true. The package manager is how you manage getting software onto your system. How do you get it on there? How do you maintain it? How do you upgrade it? And to anybody who's just coming to Linux for the first time you see a package manager, you're blown away because you're like, wait, I don't have to download something in MSI, install it, or run the installer, or run this and that. And that's a really, really big part of it. Good computer networking and SRE. We're not going to talk about that right now. We're doing this video, but we'll save that question for later. Quick opinion on Debian. I really love Debian, but I am not going to be using Debian in this boost. And for the basis of my workstation, I'm going to be using Ubuntu. Because of the extra package manager availability of the things that come. There's Debian and Ubuntu are kind of at odds. Ubuntu is built on top of Debian. Ubuntu has been, Ubuntu has been a problem. The desktop distro that I recommend to everybody is Pop! OS. If you're just starting out, if you want to throw away your existing operating system and install it, go for that. But it's really, really important that I tell you right now, we are not doing that in this boost until the end. So at this point in the boost, I want to just make one note of caution as I close this out. Okay, we have given a very, very quick video, not more than 25 minutes, about Linux. This is not enough for you to make a decision completely about what distro you want to use on your laptop. Don't make an important decision about what you're going to run on Linux right now. Wait until the end of the boost to do that. This year, we're doing something different. We're going to try all of the operating systems. So let's say you want to try Arch Linux. I'm going to try Arch Linux right now. Let's try it. You can run Arch Linux, and I have an Arch Linux, boom, from the command line. Pacman, whatever. You know what I'm saying? And I can actually try Arch Linux. Let's say I want to try, let's try this. Let's try SUSE. I want to try SUSE Linux. Let's try Red Hat. I'd probably have to be Fedora. I don't know what's the name of it. I'm just giving you an idea. We're going to be using containers because, look, I can download all of the Fedora Linux base, and I can do RPM, whatever, you know what I'm saying? And I can try Fedora, I can try SUSE, I can try Debian, I can try Ubuntu. So by using Docker containers, we are allowing a lot of experimentation and exploration, the X and RWX, with different distros so that you can make a better decision about what Linux you want to use in the end. Now, but when we go through the next step, containers, which is hopefully you might even be able to do that tonight, we're definitely gonna do it on Monday night from 7 to 9. We'll be installing Docker and installing and doing the next thing, which is getting Linux on your system, and I'll show you how to do what I just did there. And that you can do that on your Mac, you can do that on a Windows machine, you can do it on a Linux machine if you want to jump ahead and install Linux. All of that's fine. The thing I want to tell you about this though is I don't want you to make an important decision about your daily driver operating system until you can sample a few. Everybody who does this, which is really awesome, they are very experimental with it, which you should be. And the best way to do this, by the way, is get ready and get yourself an old laptop. You probably find one for free just laying around, or pay $200 for one, and then try every one of the Linux distros and download the USB and install it all and everything. I'm not asking you to do that right now though, because it's gonna stop you from getting to the rest of this stuff in the boost. And last year that was a problem. Last year we spent 2 weeks helping people set up, and we weren't able to get to some of the coding stuff later because people were distro hopping so fast and fighting over what's the best window manager and what colors they should use and stuff like that. We're not going to do any of that. We're just going to jump right to the container, and I am going to be using Ubuntu or Debian. I probably Ubuntu though, because it's the most familiar with what most people would be picking. And then after that you can, but if you don't want to, you don't have to. You can do yours as Arch, but that's next. That's coming up next. Any other questions along those lines? Otherwise, I'm going to go ahead and I'm going to put a marker in this stream. All right. Yeah, pointless tech debates. All right, so I'm going to take 5, and so you guys can go. You guys can go look up stuff for a second. I'm just going to go So this is how we're doing it. By the way, we're taking breaks in between, and then so we're informal now. You're not on camera or anything like that. You are, but you know what I mean. Bases versus tabs, really, dude. It's interesting because in POSIX you have to use spaces. In POSIX you have to use tab. There are certain commands in POSIX that won't work without a tab. I don't think I would read Linux from scratch. Look, it depends on you. You're in charge of your own learning. So I've never read the whole thing. I've seen it. I've looked at it. It is a goal of mine to build my own Linux one day. But you can understand as much about Linux as you want to just by using Arch or Gentoo. Gentoo is all compiled too. I think it's more important for you to learn how to write drivers and compile your own driver than it is to do an entire Linux from scratch. But you could. I mean, if you really want to get into embedded electronics and stuff like that, Linux from scratch would be awesome. You know, some of those engineers, the embedded engineers, they are building their own Linux from scratch. Most of them, though, are just grabbing Alpine. The containerization of the world has made it very good for embedded developers because there's a whole bunch of really tiny Linux distros, including Alpine and BusyBox. BusyBox is a Linux distro. It's so amazing. I love BusyBox. I am so addicted to BusyBox. Electronic knowledge, not a lot, but you should a lot. The reason those electronics questions are going to come up when we're doing C coding. Electrical engineers. There's a title. There's a degree you can get now called computer engineer, and they are kind of embedded engineers who focus on computers, electrical engineers who focus on computers. So that's actually a job. If I could redo life, I think I probably would get that one. That's probably what I would have gone. BusyBox is not a distro. I know that's what's so weird. It's a container, but technically, BusyBox doesn't qualify as a distro. Alpine does. But all of them are running the same Linux kernel. That's the thing about containers that gets kind of weird. They're all running the same kernel. Actually, no, that's not true. Never mind. Forget I said that. They're running off the hypervisor kernel. So, you know what? That's something about containers that I really need to look into more. I want to see whether the kernel ships with it. Is a hybrid, and hybrid usually gets cons on both sides. That might be true too. What I use BusyBox for on a daily basis? Oh God, all kinds of stuff. Pretty much every container that's serious is a BusyBox container. The ones that have applications in them and stuff like that. It's just so tiny. A BusyBox container is by default. A BusyBox container is 1.2 megabytes. An entire container running is 1.2 megabytes. Yeah, BusyBox is JQ. I was just gonna say copy Xserif. Yes. Yeah. The main competitors be WebSphere. Yeah. Snap sucks. Yeah. Alpine does use BusyBox. Yes, it does. Alpine uses BusyBox, except for it just uses an older version. Did you see this? I'll show you this. So I found this out the other day. BusyBox. So if you go into bin, sell these things. So this is BusyBox, right? Which one is that? Alpine or BusyBox? Yeah. So this is the modern BusyBox, and Alpine doesn't use the latest BusyBox. I thought that was really weird. So Alpine, yeah, I know, but it doesn't. But it's an old one because look, this uses symlinks. Yeah, Alpine uses symlinks, and the BusyBox container uses hardlinks. And I went through and looked at it, and hardlinks is the new version. Yeah, so they both use BusyBox as the shell. And that's, by the way, that's one of the reasons I've changed my opinion on Perl. I love it, but it doesn't come. These tiny little containers don't have it. All they have is POSIX shell. That's it. So you need to learn POSIX shell. Consuming inodes. Yeah, I think that's probably why. Yeah. Those are some advanced. If you're not understanding these recent comments, everyone, I just want you to understand these are Taniwa's big cloud guy. And so I just want you to understand, or girl, I don't know, but that's why. It had glib issues with Kubernetes and DNS. It was hell. What did? Copy? Oh, Alpine did? Muscle issues. Oh, did it? Really? Did not know this. That's interesting. Thanks for that input. Thanks for being here. Yeah, it's a fun topic. We are on a break though. So just so anybody else who's wandering in here, how this works, we do videos for the beginners, and then we have coffee talk and have a rest and go walk around. You absolutely can share links. Always links in the chat, unless it's like gonna get me booby banned or something. Yeah. So where am I at on my I don't even know where I'm at here. I think I'm over my break time now. Why do people keep things about keeping things not bloated? That is a good question. Is C a good beginner language? Absolutely. I think it is. But a lot of people disagree, but I think we're going to do C after shell. That's going to be our first actual compiled language in the boost. We're going to do shell first, and then we're going to do C. And we'll probably use Kona in the compiler for our stuff on that. The DNS debugging resolution. Ooh, good stuff. 2 minutes is over. All right, let's come back. Thank you, Habdams. The next topic is, I covered this already. So does Mac do Mac use Linux? No. They have BSD under the hood. Does Windows use Linux? Yes. It doesn't require it, but it has it. The Unix philosophy, we talked about that. We talked about Linux architecture. So we talked about, okay, the idea of a pipeline, and the kernel and that kind of thing. And memory. I wonder how much we should get into that. Actually, let's cover the Unix architecture again. I need to do that. All right. So, let's talk about Linux architecture really quickly. Darwin for the wins. How does Linux work? And this is really the topic. Yeah, I gave you kind of an indicator of it, but I want to do the whole thing. All right, you guys ready for this one? All right. So we're going to do another fast video, hopefully, about how Linux works. And this is from a very, 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 very high level. And as always, I'm going to encourage you to do the same thing that I would do. I would go search, how does Linux work? Right? I can try to give you that answer, but let's go see what you would find on the internet. What is Linux? How does it work? Let's see. What is Linux and how does it work? What does this one look like? Well, let's pull that up in a graphic browser and see. Okay, Linux kernel. Oh, hey, this is a pretty good write-up. Let's read from this one a little bit. Actually, this one is also textual, so we can go down and look at it. So we're going to go read this one with these guys and read it. So there's one of your answers. You're going to probably find a lot of answers, and I have no shame in searching. I'm just kind of guiding you along so you can do your own research. You're in charge of your own learning. Control plus, please. This. I'm not control plusing this. You're talking about the browser? Yeah, the browser, no. So, so this is a text-based browser, by the way, and this is one of the cases where I don't need the stinking graphic browser because it's easier to read this way. So Linux is an operating system, as we talked about. It keeps your computer running, but any device can run it. That includes, phones and toasters and routers and TVs. They all have Linux or BSD, Unix in it or something like that, and they all share a common way of working. That is not. I mean, even Windows has it at the same point. It runs on a kernel. So a kernel is some software that runs at the core that is in charge of coordinating all of the hardware that's attached to the computer, to the CPU, the central processing unit, which is where all the calculations are done. If you've heard of the idea of a core or 4-core, so we have to back up and talk about this for a little bit. So every computer, and there's tons of videos on this. Actually, one of the best YouTube videos is a really old one, and I want to send this to you as a link so you can go do your own. I'm not going to watch it, but we can do this. You can go, oh my gosh, let's go look at how does a computer work. And I wonder if it'll pull up. I do have there's a whole bunch of how early computing, there's like lots and lots of videos on this. There's actually the history of computing, which is really, really interesting. But I'm going to let you pick your own. I'm not going to give this stuff you can read, but make sure you understand this. Make sure you understand. This is it. So, computer pioneers. This is an ancient. This is one of the good ones. They'll talk about some of the ancient time. You have fun with this. Take it as far as you want, but you need to understand how these things work and what they do. And BBC History of Computers. Here it is. This is my favorite, actually. This talks about where they came from. The computer was actually a term at one point. So what does this have to do with how Linux works? Well, you have to understand how a computer works before you can understand how Linux works. And computers have at the core three parts. They have sort of the brain, which is the CPU, which does the processing and the calculations and all that stuff. That's the core of why a computer is a computer. And these days, it doesn't just have one, but it has a lot of them. The first computers that had a single core, that meant there was only one little brain that could do one computation at a time, right? Computers are limited in the sense that they can only do one computation at a time, theoretically, per core, per CPU. But you now have these chips that have multiple cores on them, and so they had to come up with this term called core because now it's like they have multiple CPUs in one. It used to be you had a CPU, and that's what it was called. The term CPU, by the way, gets used a lot for a lot of things. So a CPU is also used for a central processing unit, like a desktop. It's used to refer to a computer generally, but a CPU is the chip. So AMD 64 is a CPU architecture. But instead of saying we have an AMD 64 chip these days, we say we have a multi-core chip which has 2 CPUs on it, has 3 CPUs, 64 and more. And the future of computing is lateral, the growth in computing, and it's not vertical. So we've already maxed out how many calculations we can do per second, on a single core. And so people are inventing new styles of core. That's where you're going to hear about ARM versus AMD 64 or x86. They're all different kinds of architectures at the low level, and they all have a certain amount of technical debt that they accrue because they can't redo anything. They have to keep what they did before. And so the ARM chips that were invented for initially for phones are now getting really, really popular. And NVIDIA, of course, bought ARM. If you're going to buy stock, buy NVIDIA stock. Oh my God, they're going to own the world. And so all of this is all about getting that core faster and more efficient. But in general, the expansion of computers is going to be lateral, and people are going to be adding more and more cores at the same time, which means the programs that are written to run on these computers need to be able to run in what's called a multi-threaded environment, so they can use each one of those cores independently at the same time, and not without overly complicating the program. That the program can interact and avoid race conditions, which is one of the things that's made Rust sort of popular these days, is because it has that sort of built in, but it's not the only reason. So that's the CPU. That's the main piece. Then you have the other main piece of a computer is memory, and that's memory, like it needs to be able to remember things in order to do a computation, to keep state. And I am really simplifying this. If you're a CS developer or professor, please do not, freak out. But you have memory, and so and that's another resource. In fact, if you turn your computer on, if you go, you can run top, and you can see all of this stuff running on your computer. So you see the amount of memory. This is how many things you can do at the same time. Essentially, that's usually what's limited by memory. Memory is how much it can remember at the same time without having to swap out. In the old days, people don't do swap very much these days, but in the old days, swap was where you could write to the third thing, which is storage. Storage is something like a disk or a USB stick or some place to write stuff and go get it when we need it. It's a very slow process to go and get that and fetch that stuff. So and the stuff that's in memory is available instantly. The computer just has to put the pointer in its brain to that spot in memory, and it can instantly read whatever's there, whether it is a number or a letter, which is the same thing. We'll get to why that's true. It could be a function. They're all the same. They're all pointed to in memory. And so managing memory is a really, really big part of understanding how computers work and how the one thing that will crash your computer is maxing out your memory. If you max out your memory, your computer can't do anything anymore. It freezes and does all kinds of weird things. And that's why swap was invented. It meant that when the memory was starting to get filled up, it would start to write things it didn't need. Kind of like if you had a tiny little desk to do your homework on, but you had lots of homework, you'd put some of your homework on the floor and work on other homework that was in front of you. And then when you would switch, you'd put that on the floor and bring the other homework up and do it. That's exactly what swap is about. And so if you go, and then we have, cache. We're not going to talk about cache. So cache is, there's another amount of storage, on the chip, that's not memory and it's not hard drive disk. It's called cache, and that's memory that's instantly available. That is also on the chip. So but in general, there's these main components. There's where the brain of the computer that's doing the processing, the core of the CPU. There's the memory that contains the stuff that contains the functions and the things that are running, the actual data itself. And then there's storage, and that can either be, on the chip itself, which is what cache is, or it can be on a disk, or it could be, someplace else. And then you can add into all of that. You can add things like networking and stuff like that, which are related to devices. They are not a core. Networking is, of course, very important, but strictly speaking, networking is not a part of computer. It's not a part of the original design of the computer, which is why I think it's important that you understand, what these major parts are. They're generally referred to in the world of systems administration and SRE and stuff as resources. So if you have a CPU intensive operation, that means you have something that uses lots of CPU, and it'll go all the way to 100%. But as you can see, because I have 8 cores, I have 4, these are actually, I think this is a 4-core system with each one is a dual core. I don't remember, but that's what I personally don't fully understand why a 4-core system can sometimes show as having 8 cores, even though it only has, it's like a 4 quad core or something. So, but anyway, each one of these is basically a separate CPU. And in the past, you just had one. In fact, if you've seen really bad software, you'll see that it just spikes one, it'll just spike one CPU instead of all of them. And so it doesn't spread the load across all of them. That's a bad thing. So why are we talking about how Linux works so early in this process? Because everything from this point on is going to be talking about these things. And I cannot tell you how many people who have become full stack engineers who have no idea about CPU management and storage and process IO and these sorts of things. So this is why we're starting by talking about this stuff. Again, that's just enough to give you the information that you need to go to do your own research and really understand how everything talks and everything. And the reason I chose to learn C as the first language besides Shell this time is because when we're coding in C, there's no escaping this. You are very, very aware of of the memory and the pointers and what can go wrong. And most hacks, by the way, if you want to be a hacker, you look through the C code to see where they manage memory wrong. There's a lot of hacks that have happened because C coders have done it wrong. And C is very powerful, lets you do whatever you want, which means you can write all the way off the end of an allocated amount of memory, or assembly. Yeah, assembly is the language that talks directly to each one. In assembly, you actually program what happens in each one of these memory registers, which is a place that, that stores memory. And you actually directly by address, but which is a number, you tell each thing what to do. Okay, and it's very intensive and laborious. That's why nobody likes to write in assembly. C made it a lot easier for people above that, and then every other language on top of that is just some abstraction that somebody thought would make it easier for people to talk to computers. And that's where things get really complicated, and we're not going to go there right now. But the reason that we're starting down here at the base and going up is because a lot of people, when they start up here. And they're saying, well, why is Java a good language versus C++ versus Haskell? And now they're talking about issues that are related to managing how humans interpret complex applications before they even understand how the computer works itself down at the bottom. And so we're going to start there. We're not going to learn assembly. I wish we could. We maybe should. Maybe we should do some little assembly just to see how hard that is. And write our first assembly program, and then write C on top of that, and then build it up as we go. Okay, we're not going to be spending a lot of time doing that. We're going to learn C for understanding, not for applications development. And if you want to take it that way, and there are a lot of people here who do, you can understand it. A lot of people say that I shouldn't learn C because it makes you a bad programmer. You should learn Rust first. I actually think you need to learn C because then you'll understand why it is dangerous. Either so you can exploit that or so that you can avoid it and make sure you can have an intelligent conversation about which language matters after that. People get into the language fight and they have no idea how their computer works. All right. So what else is important? So in order to make sense of all that storage that we just talked about, there's something called the file system. Okay. And the reason this is important is because this is the most important understanding in terms of Linux that Linux brought to the table, or even Unix. Unix and Linux, there's a mantra here. Everything in Unix and Linux is a file. Everything is a file. Okay, and so, but how do we manage all of these running processes? Let's talk about that for a second. So the first thing to keep in mind is everything is a file. It's all about creating an interface between ultimately the user, that's me and you, and the computer, right? And the first abstraction that's been very genericized for all of us is in Linux and Unix land, is that everything is a file. And that includes things that are running on the computer. So let's talk about how that works really quick. And I'm running out of time, but I'm going to go ahead and give myself more time. Is that okay? Can I do that? I'm going to give myself 10 more minutes. That was only 15. So 25 seems to be the magic number. All right, 10 more minutes for me on the Pomo. All right, so everything on your computer that runs is running as a process. And actually, we already saw this with top. Let's look at top again. Actually, let me give you a better look at that. So as you can see, this is all the stuff that's running on the computer. Okay. And if one of the things that's nice about Linux and Unix is you can look at this stuff, looking at this stuff, there's other ways to look at this graphically on your Windows system. If you want to spend some time, go find your system process monitor. Mac is the same thing, but you can just run top, and you can see all of this. And being an SRE, keeping a system nice and happy and reliable, site reliability engineer means understanding how all of this works. What happens when one of these processes goes away? So let's talk about what a process is. A process is something that runs on the computer. That's it. And all of these, the operating system's primary job is the kernel runs, and that talks to all the devices. But then in order for the kernel to communicate and to coordinate everything that's happening between all of the devices and whatever the end user wants or some other system, it has to create this idea of a process. A process, and the reason it's really important to understand this, if you want to get into cloud native development, Kubernetes or anything like that, make sure you pay attention, because Kubernetes is to a large degree an abstraction that directly models a computer operating system. It's just an operating system for IT. That's why they call it Borg at Google originally. So this is how processes work. When your computer boots up, it fires off. First of all, it starts something called actually even lower than that. It'll fire something that's on the hardboard, and we used to call it a PROM. But if you were to look at your board, you would see that your computer has a chip, and it runs this teeny tiny little operating system whose only job is to hand off control to the next operating system that lives on your disk drive usually. In fact, it doesn't have to. You can actually have, if you go in, does anybody know it's called a BIOS, the basic input output system. If you can go in and change your BIOS. People have them. It's where you turn on, overclocking your CPU and all that stuff. But that itself is an operating system. It's just a teeny tiny one, and it's usually designed for setting up the permissions and the settings, the cooling, things like that, for your actual hardware. And then that allows you to boot into, that's what booting is, into another actual operating system, and that operating system can come off a network. In fact, in the old days, there was a lot of times in Linux labs, they would set the kernel, the BIOS would boot up the hardware, a tiny little, network device, a computer, and it would actually load its entire operating system over the network, and it would get it over the network and then run that. And a lot of computer universities still do this. Actually, it's really dangerous because as soon as you turn that thing off, there's no operating system at all. And so unless you've saved your stuff on a USB stick or something, if that computer goes off for any reason at all, everything on that computer is lost because there's no place to store it. Sometimes they'll do what's called network storage, and they'll have network arrays of storage, and they'll have places for you to save stuff and everything. But that's what's going on. So when the BIOS boots, the first thing that it does is it says, okay, well, what should I run? And you can go into your BIOS and you can tell it, well, I want to run from this, I want to start up from this hard drive that's in my computer, this SSD, this, which the only difference between a hard drive and SSD is that the hard drive is actually got mechanical parts on it usually that are moving around, and it's more traditional old school. And the SSD is just RAM. It's the same thing that's used for memory for RAM. It's just been optimized to be used as a hard drive instead. It makes it wicked fast because it doesn't have any moving parts at all. It's just a bunch of electronics, which is why SSD is faster than a traditional hard drive. So that's where your operating system is stored on one of those things. And so your BIOS says, which one do you want to boot? And if you want to change your boot order, you have to go into your BIOS sometimes. Then we'll get into that in installing Linux. You can even boot straight off of a USB stick that you plug in your computer and run off that. But one of those things has to have an operating system on it. And the operating system, the core part of the operating system is the kernel and the first process, the first application that runs, which in this case is init. And then init runs, and it has a process ID of 1, and it's running. It's everything that runs is essentially just looping to do something, and then it communicates and fires up everything else. And so it's important if you're going to get into Linux or anything to understand processes. So a process is, I've only got 5 minutes. A process is this sort of top level hierarchical way of looking at what's running on the computer. Everything on your computer is being run under a process as a parent. And in this case, init is the first thing that runs, and then it starts up a whole bunch of other things. And as you can see, here's all the, the parent and child, and everything gets a number. There's a limit on the number of IDs and stuff. But as you go through, you can see that they're all being run under a different number. It gets very deep. See, here's my shell right here, right? Oh, see, there's my fish. So here's my tmux running. As you can see, I have htop running here. I have Perl running here. That's the fish. That's in another window right now, but it's still running. And so, oh, look at that. That's the chat. That's me logged into the chat. So understanding Linux is largely a process of understanding processes. You have to understand that these things are all running. When you run a program, it is a process until it dies. And when it dies, its memory that was running goes away. And whatever it was doing gets unremembered. And so unless you wrote something to disk or something, it doesn't exist anymore. Now, remember I said everything is a file. So if you go back to if we go into /proc, I have to be careful what I show you here. /proc is a file system called a virtual file system, and it is not actually files. There's oh, that's fine. It's not an actual thing. There's no actual files there. So what you can do, and all of this stuff here, CPU info, yeah, these are all files that are not actual files. So every single thing that runs on Linux pulls its information from one of these things. So that looks like I just looked at a text file, right? It's actually not a text file. So it's not. It's what it's doing is it's making what's called a system call. Wait, did I do that wrong? No, let's see, it's not there. Let's see if we can look it up. Yeah, so actually that might actually be there. I doubt it though, because this is a virtual file system. What I'm trying to say is that one of the ways to make things easy for us humans is to make all of those processes you saw running on the computer also represented as a file. And most of you have had experience with the file system. You have a directory, you have files in there, you have directories under there that have files in there, text files, binary files, things that you run, things that you write stuff in. That's a file system. And so the really important thing to take away from this is that everything in Linux is a file, more specifically an inode. An inode is an index node, and this is everything there. All these numbers show what the different processes are. So you can go in here and you can see everything in here. I could look at the environment that was set up in there to run that. I can look at the exact command line that was used to run it. So I can look at the command line. Let's do that. And, I don't want to look at that one. So you can see all the different kinds of things here. Some things are scary because this is you don't want to mess around here, because this is actually representing processes that are running, and you can actually change information about the processes that are running by just changing stuff about those files. You can look at it by just looking at stuff in those files. So when I do ps tree to look at the process tree, it's actually looking at the proc file system. Okay. Now I'm not going to get into all that. I only have a minute left. I want to stay tight on this. But what I'm trying to show you is that the file system, everything is a file. There's a temp directory, which is normally thrown away when the computer reboots. And there's a place, we're not going to go through the whole thing right now, but there's a place to put all of these files that can run. And it's just, this is the file system. But what I'm trying to tell you is that everything's a file, including processes. So if that is the fundamental thing you need to understand about Linux, and we're going to be doing a lot of stuff with files. The reason everything is a file is because that makes it very easy to combine those things in the pipeline way, the Unix philosophy, which I talked about before, and to be able to do things that are very easy to get right, because they're all files. You can interact with them, you can combine them together, you can pipe one to the other one. And so the reason that it's so important that you learn the terminal is because the very basis of Linux at its core is looking at the world in terms of processes that are running, memory that is being used by those processes, and representing all of that to the end user as a file. Now, underneath the hood, if you want to know, you could actually, I don't know which one we could S-trace right now, but underneath all of this, when you run a program, what it does is it sends communications at the very high level, a very low level, to the kernel through things called system calls. And system calls is kind of like a language all by itself. And one of the reasons that we're learning C as our first language is because if you understand system calls, and I'm not even going to show you, it would just scare you. But you can actually trace a process. Let me try one. I'm over it. We'll do it. We'll do this another day. It's really fun. But you can actually trace a running process, and you can see what system calls it's using. And if you understand those system calls, you understand how it's communicating with the kernel and what it's doing. And it's really great because you can actually look at a program and see why it's messing up. Or you can audit a program and see, hey, does this thing phone home to somebody out on the internet that I don't know about? You can monitor all of those things by understanding this interaction between the running process and the kernel through system calls. Every single computer programming language uses system calls to interact with the kernel and tell it what to do, including, opening files, opening network connections, sending data, All of those things are there. Now, you don't need to master all of the system call thing today, but a fundamental part of the beginner boost is understanding how Linux works, how your computer works, and how all of this stuff is communicating, not only so you can grow up to be a hacker or something, but so that you can understand how your computer is working and how it's actually communicating with all of the different programs. And this idea of processes that are running, they have ways of communicating with each other, but most of the processes are running these system calls, and that's going to the kernel and getting processed. But sometimes when they have to talk to each other, it's called inter-process communication. There's 3 ways to do that. One of them is two processes can share space and memory and look at that same space and memory. They have to be very careful about that, but that's the fastest way to communicate. Another way is for them to talk to each other through some sort of event system. So the way that the kernel tells a program to die is it will send it an event, and that event will be that event will tell it what to do. Oops. So here's all the different events, but that's very little you can communicate. Sometimes they need to they can communicate through sockets, which are a special type of file. My WeChat does this, and they send data in and out of that first in, first out file, and they read it from that. And then we have the internet, and that's a full-blown TCP/IP stack where they actually fire up a server and a client, and they communicate either with each other, either on the same computer or on another computer completely on the internet. Those are the ways that these processes communicate. Sometimes they'll even just write to a file, and then the other program will see that file has been written to, and it'll grab it and it'll go on. So this has been a really, really whirlwind introduction to how Linux works, how all of the pieces communicate, what the core infrastructure is, and why you care. You need to understand this when you start talking about killing a process or sending it a signal or interrupting. When we start doing the VI thing, and I tell you that you don't want to use Control-C for escape because it sends an interrupt. Now you'll understand what I'm talking about. You'll understand, well, what's an interrupt? Well, an interrupt is an event that's designed to kill a process, not to change the mode of VI. And so hopefully that'll give you the basis for all of that. All right, I'm going to spend some time reading the chat. That was quite a bit of talking, but I tried to summarize all of Linux architecture in 25 minutes, so give me a break. So let's see what we got here. I'm going to read from this a little bit. I'll let this be on stream, and then we'll go. All right, so C and C++ are not the same as syntax. Absolutely not. Absolutely not. Network boot, some universities used to use it. Yeah, you could get a TTY by logging in. That's interesting. Yeah. Let's see. File. Oh, did I say file and not type? I'm sorry. I feel silly now. All right, thank you for catching that. Was that what I was typing the whole time? I feel so dumb now. It's not, it's type. No, that's not it. I was trying to, yeah, it is file. File tells you what type of file it is. So if I said, I could do file temp foo.md. Yeah, ASCII text. We're gonna do that later. All right, so I think this video is about done. And let's see. Everything is a file. Sounds like a Matrix movie. It does. And if you can say everything's an inode, you can be cool. Yeah, I do know 127.0.0. Okay. So that's it for this video. Thank you for joining, and we'll see you on the next one. But honestly, there's a lot more videos that are way better than mine that will tell you how Linux works. This is me trying to tell you how Linux works in 25 minutes without visual aids. But again, the purpose of Beginner Boost is to get you enough information so that you can say, what did he mean by that? What did he mean by that? What does this other person have to say about that? So as we talked about in the other videos, the goal of this is to help you go ask the right questions. And now hopefully you know the terms to search and research on your own. And I suggest for your homework that you spend at least at least 8 hours researching how Linux works and processes and what they are and CPU and storage and what the difference is before you go on. If you truly want to get certified in Linux, there is the Linux Foundation that you can help do that, but that's a separate video all by itself, and I want to talk about that right now. All right. So let's take a break and let's do this. I would not do Linux Plus. I absolutely would not do that. We need to talk about Linux certification all by itself. You couldn't pay me to do a CompTIA. Unless you're getting it for free through your company or something, I just would not do it. I mean, we're on a break here, so if you want to talk about it, we can. I would use, the only training that I recommend is the Linux Foundation training. Which is, Linus Torvald is part of the Linux Foundation. The LPIC stuff is pretty good too, but honestly, you don't need to certify. Red Hat is an industry standard. If you're going to be working with Red Hat in the enterprise, if you're going to go get a certificate, that's fine. Since the topic of certification came up, it's really important that I mention that you may not need it. Damn, I'm going to give myself an extra 5 minutes. So I did a vid on this, why certify, and make sure you watch that, make your own decision about certification. I don't think you need it personally. So, it's more important that you actually have, you played around with it and you can mess with it and talk with that stuff like that. Write your own driver for escape key. Yep. Thanks for all the joins today. It's been really fun. And what will we do next? Let's see if we can get, we do have a half an hour left tonight, and let me go see what's on the agenda. Let's see here. When and how should I install Linux? Okay, actually, I do want to talk about that with its own video. So we're gonna do that one right now. You guys, I'll give you guys a break. I don't want to lie. So at 8:28, we're gonna probably close with that video. I kind of mentioned it in the other one, but I think it goes without saying. Did that link actually work or not? Yeah. Until an employer specifies a cert. Yeah, I would not. Yeah, particularly if you're doing cybersecurity stuff. If you're doing cybersecurity stuff, it really depends on what you're going for, right? In January 2020, when I started Twitch streaming, I was big into OSCP. I did a lot of research on what cert to get and everything. This is before I discovered that most of cybersecurity is writing reports. At least half of the job is writing reports. And that was when I realized I didn't want anything to do with it. I think it's fun. I like hacking for fun. And there's a lot of really great places to go hack, but there was just no way I was going to do that. And every day as a job, because I think hacking is really, really fun. And if somebody's going to tell me that half the job is not hacking, then I don't want to do it. So, yeah, I think it's way more fun. Yeah, if you want to, here's we're still got a couple of minutes here. Mr. Robert doesn't include a lot for that reason. Yeah. Yeah, into breaking into a system, right? Get hacked in advance. Hey, VMT. A lot of people have been talking about embedded stuff, VMT. If you want to chime in, guys, just so everybody knows while we're on break, VMT is one of the better embedded engineers in the community. It spends a lot of time in C and BSD and stuff like that. So we have a number of people in the community who are, professionals who are doing this stuff. So they might help you find your way. And by the way, everybody's in the Discord. I don't ever go to the Discord, but if you want to join the Discord and you want to ask these questions, there's a lot of people giving each other career advice and guiding them professionally through different Unix, Linux related careers. And so you can ask those questions, offline or online. You can always drop by the IRC and ask the same question. But my hot quick take, since I have 2 minutes left, on jobs, and I'm really, really glad I did this. So just a short story. I was an enterprise, developer and engineer for years. And then, I took my own money out, retired kind of partially 8 years ago, and started SkillStack to help people learn, as mentoring kind of form. And then I had to go back and get a job for insurance and reasons this year. And you can watch all the saga in my VODs if you want. But, and I decided that I wasn't going to go into cybersecurity, and I went into infrastructure engineering with cloud native infrastructure. And I spend more time on the command line now than most cybersecurity pen testers, because they're doing reports and stuff. And I'm really glad I did that. So to me, I'm going to call it the Matrix Neo school of getting a job. So Neo did a lot of hacking on the side and had a lot of fun with that, and did whatever he wanted: bug bounty, gray hat, black hat, whatever you want, and did it recreationally, so it remained fun. And then during the day, he was a systems administrator, and he did a lot of coding, and he did a lot of terminal stuff. And because I did infrastructure engineering and cloud native and Kubernetes and containers and stuff, this stuff pays really, really well, but it also keeps you on the command line. I don't have to do reports or anything at all. I do write, my stand up, and occasionally we'll do a SharePoint, the document is something, but there's almost no documentation. And if I had done cybersecurity as a profession, half of my time would have been writing up the reports instead of just on the terminal. And every day I would rather spend time, on the terminal doing something. So I'm really glad I stayed in the infrastructure engineering role, doing that. And the difference between that and becoming a developer, and I do love development, is that developers are under a lot heavier pressure to hit deadlines and stuff, whereas infrastructure engineers are constantly adapting, and they get new challenges all the time, because like today, integrate Jupyter Hub with our interface infrastructure. Tomorrow, maybe write a script that reports on how many nodes we have in our cluster and what state they're in. There's just constant variety in the infrastructure job, and that variety is in sync with the pen testing, hacking kind of thing as well, because you're constantly dealing with something new, and you're writing scripts a lot. You're doing code, but the code is related to infrastructure kinds of things, and you're modifying applications, or you're breaking them, or you're reporting on them occasionally. But when it comes time to hacking, then you can also do that on the side, and the activities every day on the terminal are the same. If I were to just do software engineering, I might spend the entire day in VS Code or something, and never look up. Right. And I would just be doing that. So if you're attracted to hacking, I really want to encourage you to look into the infrastructure engineering, SRE, cloud native space, because, DevOps, because that stuff is largely consistent with the daily activities that you enjoy with hacking. And so then you're making money doing that stuff, not really particularly hacking. Maybe you're auditing or something, and then you can move to the other thing. Okay, so that's my take on that. Being a generalist or specialist. Neo is old. Yeah, I'm that old, so I can refer to Neo. Yeah, The Matrix is one of the movies that defined me. So I don't care if it's an old movie. It's still one of the best movies ever made. A good report has parts for managers, and then a more extensive part for actual mediation. Yes, it's true. Yeah. Hackers hate DevOps from what I've heard. Yeah. Well, they might not like DevOps, but if they're writing YAML all day, that might annoy them, right? That's what I'm saying. Infrastructure engineering, SRE kinds of stuff might be more fun for a hacker to do daily. And a new part. Yes, sirree. All right. So let's do this other video here. And I'm looking forward to that. Does anybody know when it's coming out? I am not I'm not going to lie. I am a massive Keanu Reeves fan. At every level. The guy is just so cool. All right. So let me see here. Let's do, oops. When and how should I install Linux? Okay, so this is a huge question. I actually talked about it a little bit, but I'm going to talk about it again. Why would I not like Keanu? I mean, he's one of the... I do. I'm a major fanboy. I'm a major Keanu Reeves fanboy. I ain't gonna lie. I just... Yeah, it's like... All right, you guys ready for a video? Oh, whoops. I did the wrong thing. All right. Why does it always say 9 minutes? I got to do that over again. My promo duration. I got to go back to 25 minutes. My God. Duration. Because I'm making 25-minute videos, so. All right, there we go. All right, so we're going to add a stream here thing. All right, so another video to conclude for the evening. When and how should I install Linux? I mentioned this a little bit in the other video, but I want to talk at length about this. Hopefully it's not a whole 25 minutes, but we'll see. If you're in the studio audience here, all 95 or so viewers, go ahead and chime in. Please try to keep it on topic if you could. I would appreciate that. It seems ethical hacking. No, that's a great question though. We were talking about how Linux appeals to hackers and stuff like that, and hacker-ish careers, and how being an infrastructure engineer might actually be what you want instead of a hacker, since you don't have to write reports. It's another subtopic which we'll cover later, but it does involve Linux. There's no doubt that Linux is the #1 operating system for people who want to get in to engineering, get their hands dirty, either writing code that runs, that interfaces with devices like Linus Torvalds originally did, who invented it. And it's just a really great tinkering language. Raspberry Pi, you may have heard of it, is running Linux. But the question always comes up, and I got to start right now. I've said this at least 3 times on these videos. Every time we hit this part in the boost, we get side railed, and we get side railed by talking about distros and comparing them, and what should I do, and should I dual boot, and should I run off USB, should I do this, should I run a container? And I want to talk directly about that for at least 15 minutes so that I can justify the position and possibly convince you to not, overreach and start to do this right now and stop yourself from being able to keep up with what the other stuff that's going to happen on the boost. Because last year, a lot of people got hung up on this Linux thing because it's exciting. If it's the first thing you've ever used Linux, it's extremely exciting. And it's really hard to not immediately want to make that your daily driver everywhere. And it's really easy for you to get derailed and not be able to keep up with the other stuff from the boost because you're spending so much time installing Linux. And we're not going to talk about distros today. We talked about distros in the history of Linux. Go back and watch that video. For the sake of time, I'm just going to tell you what we're going to do in the boost going forward, and then I'm going to tell you what I think you should do at the end of the boost, or on the side if you have an extra computer you want to do it in kind of a parallel effort. But I don't want you to do anything with installing Linux that's going to derail you from staying up with us on the boost. All right, so first of all, what does it mean to install Linux in the first place? Okay, so because Linux, it's very hard to buy a computer with Linux on it today. You have to put Linux on the computer and you have to install it. And the process of installing is not overly complicated, but it's not the same as turning your computer on and clicking a button. The process generally involves to put Linux. There's basically 3 ways to run Linux. 3 or 4, actually, no, with containers, because that's like probably 5 now, right? Well, I don't know. Let's not count them. Let's see how many there are. So the first way to run Linux is to just run it from a container. And that's what we're going to do for the boost. And this way has pros and cons. So so we can run Arch Linux. All right, so you might have heard of it. You want to try it. You can try it out right there. You can just run it as a container. This is Arch Linux running on my computer in a container. And in every way, it is actually Linux. In fact, I could even have it send me graphic stuff. There's a really great video from Jess Frazzle about her. She's actually running Steam games from within a Linux container. In fact, her computer, when she boots her computer, it just boots into containers. It doesn't even have an operating system. It has a teeny teensy bitsy tiny operating system, and then every time she turns her computer on, she runs a container even that has graphics. And so that's the way that we're going to do it, and that's why I'm going to put that as reason number one, the way number one that we're going to do it. If I want to run Ubuntu, which we're going to do, I can run Ubuntu and I can try it out and do all of that. And when I turn it off, it goes away. I think you might be running cubes. I don't think it is cubes. No. So if I want to run Debian, I can run that, and I can run Debian. Now I have Debian. So this is by far the fastest way to run Linux and try stuff out. And you can use this for all kinds of reasons. And we're going to talk about containers in its own series. But containers, those are legitimate versions of Linux that are running in a container. And a container is in every way is a computer kind of inside the container. Now, it's not technically a computer because it's sharing the main kernel that we talked about with the underlying system. And I don't want to get into that right now. So it's not the same as a virtual environment, a virtual machine. And that's the next thing we should talk about. So the next way to run a container would be using something like Virtualbox or VMware, which are virtual. Virtualbox is a free and open source hypervisor for virtualization by core. So what does that even mean? That means, so here's the graphic version of it. So Virtualbox, which is a company that was bought out by Oracle. This is a computer. This is a virtual machine. So this is a machine in every way. This is exactly like a machine, including the desktop environment and everything, but it's a beast. It takes a lot of memory permanently. It's really slow, depending on your computer. It is a good way to test things out. You can run Windows in a virtual machine. You can run Windows in a container as well. But so just give you an example of when a virtual machine would be important. So if you want to get the OSEE, the open, what is it, offensive security exploit engineer expert or something, you have to have a laptop with at least 8 core CPU, and you have to be able to run VMware or Virtualbox. VMware is the other one. That's the big one. It's expensive. It might be worth it if you're going to do this. Oh boy, VMware is the other one. And so VMware is another way to run it, a computer within a computer. And in every way, it's a computer. When I used to run Windows on Linux and play Dota 2 in Windows from my Linux machine, because VMware had really good GPU pass-through for your graphics processing unit. We didn't talk about that at all in the how Linux works thing, because at the end of the day, the GPU is just another device, a very important device, but it's another device. And so running VMware is a very, very important thing to understand in the enterprise. If you're doing networking, it's important. So the reason I mentioned the OSEE is because they require it, because they want you to run Windows on there and then hack Windows as a virtual machine. Obviously, hacking a Windows machine running on hardware would be a lot harder, because you can't reset it and try to break it again, and reset it and try to break it again. So when you want the exact duplicate experience of Linux or Windows, there are some ways to run Mac even in there, even though it's illegal. Then you would want a virtual machine. So that's another way to do that. However, it's very slow and it's just not fast. Virtual machines came out before containers came out, and both of them are built on the same sort of technology underneath, which we won't get into. But it's important that you understand that those are two of the ways. So I get questions all the time. Well, can I just run Linux? People, generally speaking, people want to keep their Windows so they can play games or something, and they don't want to go through the hassle of that. If you truly want to experiment with Linux and not have it affect your computer, whether you have a Mac or a Windows machine, a virtual machine is probably the best way for you to test what the experience is going to be like, even though you won't be able to test things like, will it run my game? How fast is it snappy and stuff? You can't test any of that because it's running under a virtual machine. And so we're going to move on to And yeah, I don't know about that one. So there's a number of other virtual machine tools out there. Yeah, and so a lot of people start out with virtual machines and then they dual boot. So let's talk about dual booting, particularly gamers. And I started out as a dual booter too. I'm going to tell you a big, huge warning sign right out the gate. I cannot tell you how many people have totally screwed up their systems dual booting to the point where they've almost bricked their machines. And breaking a machine means that you just it doesn't boot. It's just black. It's just a prompt. If you really, really do not understand low level stuff, and you don't want to understand low level stuff, you like mess with your MBR, your master boot record, and you get your boot processes wrong, and now you're in really, really serious stuff, like really serious stuff. So I cannot tell you how many times. What dual booting is it's basically you take your existing operating system, usually Windows, and you cram all of this stuff on this disk drive into a partition of the disk drive that's about this big. A partition is just how you break up the disk. And it's all on the same disk, right? And then you can dual boot off two different disks internally or externally, but most of the time it's on the same disk. And so people will cram all the stuff in here. And then what your BIOS does is when your booter boots up, your BIOS says, which operating system do you want? And it will start you up here, or it will jump over here and it will start this other partition over here. But you got to understand, there's a lot of other stuff on your disks. And unless you don't want to get into the deep low-level details of disk partitioning, which is not beginner stuff, Linux Mint does a really great job of disk allocation and stuff. Pop! OS does not. Pop! OS is an operating system that's designed for beginners that are not going to do that. They'll want to run it on their operating system because it was actually made by System 76 to run on their hardware. So it doesn't dual boot very well. Linux Mint does dual boot pretty well. But I'm telling you right now, and I'm just going to straight up say it, don't dual boot. There's almost no reason to do it. I dual booted in my computer lab because I had to. And, because I wanted to be able to sometimes boot into Windows and I wanted to boot into Linux. It's almost always a bad idea. And every one of the other ways we've talked about will usually cover your case. A virtual machine is too slow to really be useful. Every time I've dual booted, by the way, including in the lab, I've found that I ended up wasting most of my disk for Windows because I booted Windows maybe once every 2.5 weeks for a birthday party or something, right? It's almost always a better idea to identify another computer and run that computer with Linux and have your main computer be Windows. In fact, if you get like an MSI Trident, sometimes called a console killer, you can get that computer and have that. It's got a kicking GPU in it, and you can have that be your Windows PC, boss PC if you want to have it be that, and it will run it in max settings, and it costs like $1,000 or something. And or else you can go down and get a laptop and pay $200 for that. So we're coming to the main way to run Linux, and this is the way I'm going to recommend to the most people to do this. If you want to run Linux, run it on hardware. Go through the process of installing it on the hardware. Why? Because first of all, it's going to be Linux. It's going to be actually Linux. You're going to get an extreme amount of experience installing it on the hardware, knowing how to do that. You're going to get the maximum performance. Linux is not going to be confused about any of the virtualization of all of its devices because it's hard enough dealing with Linux and devices as it is using real devices, let alone virtualizations of those things. So find yourself a computer. Honestly, Linux does not need a lot of power. In fact, I used to collect old computers that people thought they were going to get rid of, and they're like, I got my taxes on there, I can't give it away. And I'm like, I tell you what, I will wipe the whole disk drive and you let me have it and I'll give it to somebody. And I would put Linux on there and it would cook because it didn't have to run whatever operating system got bloated out of the ability for it to run, including Macs. You can take, I've got a bunch of Mac Minis that are running Rancher OS right now, and they're just flying because a lot of these Windows and Mac, they keep pushing the operating system bigger to sell more computers, but you can like throw that away and put Linux on there. So my suggestion to you, and you can prepare for this, we're not going to talk about how to do this until the end of the boost, but over the time of the boost, keep your eyes open for an old computer, and I'm talking even like 10, 20 years old. You can put Linux, Ubuntu on there. You can even, if you want to, you can throw out the desktop OS, but you can use, there's so many different versions of the Linux desktop that will run with very, very, very little resources. And you can make that into an amazing system. You can have a server in your corner that's serving up web pages or running Minecraft servers or running, pen testing hacks and stuff like. You can do whatever you want. And in fact, it's kind of addicting. You'll end up starting to gather old hardware and putting them on your network because Linux breathes new life into hardware. That is by far the most enjoyable, the most educational, and the most useful way to run Linux. Actually putting Linux on the hardware. If you dual boot, the biggest problem with dual booting, I also want to say, is that Windows, whatever version of Linux, if you're going to put Linux on there, there's a good chance you're going to want to distro hop. You're going to want to experiment with lots of different distros. You're going to put Arch on there. You want to maybe do an LFS. You maybe want to do Gentoo. Every time you do that, you're taking your entire life into your hands because any one of those Linux distros has permission to blow away the disk drives for your Windows partition. So if you haven't backed it up or anything, inevitably you end up screwing this up. And I cannot tell you how many times, including my own systems, I have blown them away because one of the things I want to learn about Linux is how it deals with disk partitions. Well, you can't experiment with disk partitioning if you dual boot, right? Once you get a good dual boot running, you don't touch that thing ever again. And you pray to God that some update for that Linux distribution is not going to suddenly decide to take over the Windows space or vice versa. Some Windows installation is not going to understand Linux is on there and just accidentally blow away your Linux partition, both of which have happened to me in the past. So I cannot recommend enough keeping, don't cross the streams. Get yourself a Windows machine for gaming. If you want to do Linux on there, use Linux containers, which is what we're going to do for this boost. Like I told you can run that on anything. It can Docker Desktop will run on anything. It runs really great on Windows, actually. Use WSL on Windows Desktop for Linux. If you don't, that's the fastest way to do it. Learn the terminal. You probably, if you're running Linux, you're not going to really care about i3 and desktop managers and all those fun things that Linux porn and Reddit and stuff like that. You're not going to care about that because you just want a terminal. You want to get something done. So if you just care about a terminal, containers are the way to go. And if you want something that has a graphic element, use a VM for virtual machine or something like that on Windows. But until you can get an extra computer, and then just get that computer and put Linux on there, and then try every Linux distro you ever wanted from scratch. And keep yourself a collection of USB sticks that you can install on there. Kali Linux for a while. Maybe you want to boot into that. You can play around with it all. The whole point is that Linux is an experimental OS. It's designed for you to really get into the guts of the devices and look at how things work. And you can't do that if you're hobbled by a Windows partition that you're trying to get pristine because, oh my God, I don't want to lose my game cache on there. Bad idea. Don't do it. All right. Did I convince you? Yeah. Terminals will tell you terminal velocity. So in a nutshell, the TLDR at the very end is don't dual boot. Install Linux on its own. Look for a computer that's reasonably small. You can get a kicking computer at like Walmart for $200 that will run everything Linux like at top speed, and you're not playing games on that thing, right? And then what? Yeah, go to your local e-waste centers and do that and run Linux on your own hardware and learn how to install it on that. And then whenever you need the power of a Linux terminal, use containers for that instead. And that's what we're doing for the boost. All right. Thanks for all the follows, guys. So for sub $50 on eBay. Oh my God. Seriously? I might have to go buy some. See, here's another thing you can do. You can buy all that old hardware and you can make yourself a Kubernetes cluster. You can put Linux on all of them and then make them into like your own Borg. And then you have all that processing power that can do, you can run like pen testing stuff on it that just trolls the internet the whole day, all day, and looking for stuff to hack. That's actually a goal of mine, is do that. Raspberry Pi, yeah. Raspberry Pi is a really good option too. A Raspberry Pi comes with Linux. It's actually one of the cheapest ways to get into Linux. The problem with Raspberry Pi is how long it takes to compile stuff. The new Raspberry Pis are pretty damn fast, but I remember compiling Minecraft and waiting for like an hour and a half on the old one. So that's my only downside with Raspberry Pi, but I do really love Raspberry Pis. Yeah. Onion's another good one. You try to purchase those. I need to take a break here. I think we're probably done for the night. Actually, that was the last video. Clusters, yeah. I'm gonna make a Raspberry Pi cluster for Kubernetes. And so I practice my nodes, my node management. I have a bunch of old Mac Minis too. Mac Minis take Linux. There's actually what was it? I got a news and whatever, an email I regularly get. I think it was an open source newsletter, and it's like breathe new life into your Mac. Yeah, you can on most Macs you can run Linux pretty well. The new MacBook Pros don't. They have some problems with it, and some of the device drivers are not supported. Of course, the new ones are not going to run it at all. But if you want to like breathe new life into old hardware, that's the way to go. There are hats for Raspberry Pi that allow you to mount an SSD. Yes, there's all kinds of stuff. They make build flags. Next project is to set up a Pi cluster. I know, it'd be so much fun. The Pi clusters are so. Have you seen the racks they have for them on Amazon? Have you seen these? Since we're winding the boost down here, we got 10 minutes to just shoot the breeze before we have to go. But so yeah, Amazon.com. Let's see if I can go find them. Raspberry Pi. What is it called? It's a rack. They have a. You could probably make one. Yeah, they have all kinds of Raspberry Pi racks. Oh my God, look at this. This is new. I haven't seen this one. Oh, that's so cool. Look at that. Oh my God. These things are hitting mainstream, man. They're getting powerful. You seeing this? This is so cool. Oh wow. Yeah, look at that. Oh my God, that's so cool. I love the Pis. The Pis are so much fun because you can do so many things with them. But they have other ones though that are more like, they're more cool. They're like, where is it? There it is. Yeah, for the 4B. Yeah, NVIDIA Jetson is also cool. Yeah, there's a lot that are really expensive. Look at this, man. You can stack them all, and they're absolutely silent, man. You put these things on and stick them in the corner, and if you get, you can port forward, or you do DNS. You guys know about DNS. You can set up dynamic DNS on these things, and you can basically put a server on the internet. I haven't tried it in my provider now. Make sure you get your heat sinks, by the way. You got to get your heat sinks. I tried to overclock one, and the 4B will actually run a Minecraft server comfortably. Yeah. 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 These things are fun. They are really fun. And if you get you guys know about PoE? Is Bob there? My network guy. Power over Ethernet. If you get a PoE, did it get DDoS? I did not know that. Okay, the thing about this is if you get a PoE, you can have Raspberry Pis powered by Ethernet. Now, yeah. So if you get the right router, if you get a PoE router, you can put these Raspberry Pis all over your house or wherever and just run an Ethernet cable to them, and the Ethernet cable has power. So you can put them anywhere. All you have to do is run PoE power to them. So they have power over Ethernet now. Oh, I don't know if I want to read that right now. Oh, thank you for putting it out there, though. One cable to rule them all. I know. PoE is so cool. I am going to PoE our new house. We're buying a house this year. I'm going to PoE our house like crazy. I'm going to have stuff everywhere. I'm going to have security cameras and like the bird feeder and the bunnies on Twitch or whatever, I don't know. Just, yeah, it's just because you can do so much with them now, and you don't need Wi-Fi. I mean, you can actually do Wi-Fi as well. Wi-Fi is even cooler because you can like get my friend Gabe. He got a really high powered laptop battery. Phone recharger, and he hacked the cables to provide power to the Raspberry Pi, and it gives the Pi enough power to run for like 3 months, and you can put that Pi anywhere. And if you put one of the new chips in it, if you put one of the new like SIM chips in it, you can put it anywhere. So people are like setting up Raspberry Pis in the middle of nowhere, and they're communicating over 5G or 4G, and they're just all over the place. It's just really cool. I love that I'm alive in this time, because I told you I like going outside and doing stuff, you know. So the Raspberry Pi brings a lot of stuff to the table. And yeah, I thought there were some more racks since then. No, you have to get an extra thing, Leonardo. Yeah. You have to get, I don't remember the name of it. It's yeah, well, they run off micro SD. You can get solar and battery power too, yeah. I haven't done that yet. So I mean, this is all stuff that I want to do for fun, you know, that I'm really into. But and by the way, all of this stuff runs Linux. So you can put BSD on there if you want, but I would put Linux on there. And it's another, oh God, look at that one. See, that's kind of cool, huh? Look at that. It's your Pi case. It's like cool to have one Pi, and then you can get like 3 Pis or 10 Pis USB modem. Yeah, they have USB modem on them. There's lots of, yeah. On the cluster, I am for sure. Yeah, my cluster is going to be all K3OS. I might have 1 or 2 Red Hats in there with kubelets on them, just because that's what we have in our internal infrastructure at work. So I need to, you know, I have to put some Red Hat nodes in there. A node is a computer that's been added to a Kubernetes cluster, and by the way, the way that works is they put some stuff on there. They put some applications on any computer. Any computer can be a node, even your own workstation. But bad idea, right? And then the kube control, the kube admin and the kubelet. There's software that runs on the computer that manages the resources and CPU and everything, and it schedules container to be run there. And when we come back to containers and images and stuff like that, this whole conversation about processes running with the CPU is going to become relevant again, because there's direct corollary to that architecture on a macro scale. Yeah. Running Gentoo. Matt, never. You kidding me? You know how much time it would take in compiling Gentoo on each one of those? What are you going to do? Compile all your stuff in advance? You could, Gentoo, you have to compile everything. And unless something's changed, there's no way I would do that, because it's just too much of a hassle. You know, Gentoo is good to put on like old hardware though, that has reasonable speed for compiling. Yeah, in case anybody's wondering, Gentoo is a distro where instead of installing packages and stuff, you compile software every time. Every time you oh my gosh, look at this one. What? Yeah, every time you install anything. So you want to put VI on there, you have to compile it. And compiling things takes a while, even with a powerful computer. So yeah, that's not bad. I like that rack. That's a pretty cool rack too. HDMI over Ethernet exists. It does, doesn't it? You would need is USB over Ethernet. Ooh, one cable to rule them all. They'll do that. I mean, God, this USB-C stuff. My laptop here has one USB-C. It's actually not USB-C, right? It's Thunderbolt, I think. It has one cable, and I put the computer down and plug that cable in, and everything connects. My KVM, the power, the monitor, everything. Actually, no, the monitor doesn't connect. No, it does. The monitor does connect. Yeah, everything connects over it. That's insane. Like, why didn't they start with that? We had to like live through all the other stuff. It's 9 o'clock. I'm gonna go raid somebody. So I thank you very much for coming to the beginner boost tonight. The next one will be Monday, same times, 7 to 9. I'll be posting this VOD unedited to YouTube, and of course you can go see the VOD immediately, and such. In fact, for that reason, I am probably well, let's go ahead and raid somebody, and then I'm going to can the stream. But I'm gonna put a mark in here, so in case anybody wants to know. Yeah, I'm just gonna add a stream marker and say this is the end. It takes about like 5 minutes for me to find somebody just to raid every time anyway. So, Optic Thunderbolt. I think that's the one I have. Yeah, I think that's the one I have. I didn't buy it though. It was issued to me. Argentina, how's it going? Thanks for coming by. Anybody who wants to catch up on the beginner boost, the other videos are there. You can go watch them raw, or you can watch the highlights. The first night of the beginner boost, day 0, I stayed up until 1 a.m. Editing highlight videos, and I'm not going to do that anymore. So what I'm going to be doing for the boost is I'm just going to be putting out the whole 2.5 hours or so to YouTube and to here, and then I'll try to mine out highlight videos over time from that, given however much time I have. But I can't do the highlighting right away. It just takes too much time. So that's what's going on. Saturate the link within 0 seconds. So who should we go find? Oh, hey, look. Now, I haven't seen him right. I like Downright. He said a lot of amazing things. He was doing some BSD at one point. I haven't seen him on for a while, actually. I think he's the one very famously said once that the college was just remedial education and to get you ready for everything else. Who else we got? All right. Oh, Jan's over there. It's okay, country with being in the UK. Military secrets. I kind of want to raid Downright. I haven't seen him in a while. I haven't seen him on in a long time. So I might have to do that. Hello. Hello. Let's see that. Oh, Pon's already headed over there. Who else we got to raid though? A girl with a box is nice. She's fun. They're all good. Boy, there's not a lot of people on tonight. It's weird. People are actually doing stuff, I guess. I mean, who else is in Science and Tech? Can we go say hi to? We've got Tormentus. I have them organized. Hi to low. What? EJ's Space and Rocket Review. Cool. Wow. That's cool. Don't know that person. Oh, there's us. Me picking my beard. This is the hard part. This is the hard part of streaming. I haven't seen Downright for a while, so I might as well grade him. Go Nginx working Cophobia. That looks fun. What's he doing? Can you see his stream? I know a lot of the people that watch me are into cybersecurity as well, so I might as well raid Downright because I haven't seen him in a long time. It's just been a long time since he's been on. Why did Sun go to school? What the hell? I don't know what that means. Links Gamecast. Ooh. Guys have any votes? I'm sure you don't. Planks. Old coder chick. Oh, she's got to get rated. She's totally getting rated right now.
Array with the youngest age, comma, the oldest age, comma.
I'm totally rating her right now. We're gonna sneak up on her. I love rating people who are just learning who are brave enough to stream. It's one of my favorite people to raid. So please say hi. We're gonna go ahead and raid them, and otherwise I'll see you guys on Monday. I'm actually gonna be back tonight writing a lot of code. So if you want to watch some shell scripting and how to build a .files container and stuff like that, I'll be here. I can answer questions a little bit, but I may or may not be on stream. I might still be visually on stream, but we're going to go raid here for right now. This ought to be fun.
array the way I do. So, oh, hey. Oh, wow. Man, I'm getting rated. Hi, guys. I don't have any perks for you. I don't have any emotes. I've got nothing. I've got nothing except for some coding problems in JavaScript. And yeah. Oh, you're not into perks? Well, that's good. You came to the right place. You have rated the correct stream because I've got nothing for you except for some code.
That's great.
Yeah. All about the code and learning. I think the folks in chat are actually better equipped to tell you all about what I'm trying to learn here. And this particular coding exercise kind of speaks for itself. Yeah, there's a lot of conversation. We're kind of short on the code and long on the conversation tonight because it's Saturday night wine and coding, and I came here a little bit wined up. I don't have any wine now. I've got my energy drink, but yeah, we've got that going. But yeah, we're doing JavaScript. I don't know if you guys are doing JavaScript where you come from, but we're doing some JavaScript and we're working with array methods. So it's good times. It's good times over here. Good times over in our console. So, okay, you guys, we've got one more coding exercise and then we can move on to Code Wars, which it's already 9:07, so we gotta get this going.
Okay.
So I gotta do this.
Okay.
So we are.
Take care, guys.
Yeah, JavaScript is super empowering. I've heard it's not the best for everything. I don't know enough to say, and I don't think it would be fair for me to say this early on in my coding career. But I mean, it's good to start out with, right? Because you got to start out with something. That's my understanding.
Yep. All right.
That's my
guys.
story.
Take care.
Stick with it.
So hopefully you guys, I will be back later, but for right now, you guys can hang out. If you're still watching, I'll be back later.